Like we always say, some of the stuff you're going to be familiar with and some of it you may not be familiar with. Okay? So let me know if I click too quick or no questions. Okay? All right. So definitions, guys, you don't really have to write these down if you don't want to, but a solution to an inequality obviously is a number that's going to work when you substitute it into it. A conditional inequality has at least one number or solution in it and one number that's not a solution. An inconsistent inequality is one with no real solutions. And then identity has every number is a solution. Okay, so this would be a no solution, all reals kind of solution that you've done before. Okay, so here we go. When you solve inequalities, are the steps any different than when you solve an equation? No, you kind of do the same thing. We're going to subtract 3 from both sides, and then we're going to divide by a negative 4. Now, when you divide by a negative or multiply by a negative, what happens? This inequality symbol will flip around. Okay, so if the number with the x is negative and you end up having to divide by it, the symbol will flip. Okay, and then you graph it. I don't care about all these lines. I'm just going to pick one to make it as negative 4. And it's closed circle to the left, and we already know how to write this as an interval notation. Remember, if it's closed circle, you're going to do the square bracket. All right, so inequalities, same steps when you solve an equation. You are just keeping track of if you have a negative. So I'm going to move this x over to join the left side. So only if you divide by a negative do you have to flip that symbol or multiply by a negative. Okay. So I'm assuming we all remember how to do that. Right? Hopefully. My line's not straight. All right. Now, if you have fractions, again, same thing as if we were solving an equation that included fractions. You want to eliminate the fractions. So how do you eliminate fractions in an equation? You want to remember? Multiply by the reciprocal if you're solving for x. That's your last step. So you're right, but clear fractions, what do you do? Yeah, multiply by the common denominator, and that's going to get rid of all your fractions. So what's our common denominator here? 6. So if I multiply this first guy by 6, every guy gets multiplied by 6. Every single term. Okay? And what that allows us to do is the denominator should divide into that and gets rid of the fraction. This 2 will divide into 6 and become a 3. So that's going to be 3x. There's nothing to divide out here in this last term, so you just multiply by 6. So now we don't have fractions, and we can go ahead and solve that. So you're multiplying each term by 6 and dividing any denominators that you had out. And then distribute whatever. Okay, so I'm going to bring this 3x over. I'm going to move my 6 over. And I have a negative x. So when I divide by negative 1, it flips my symbol. Okay. So really clearing the fractions. Because is what you have to remember there. So why don't you guys try that second one so you can clear the fractions. Okay, when you're done, look up and make sure you got what I got. Greater than 7/4. Okay. You guys have to watch me. I made lots of mistakes this morning. I think I've perfected myself by today, this afternoon, but this morning was lots of little things. Okay? All right. Compound inequalities, when you have an and or an or. So an and statement generally will result in an answer where that's between two numbers. Okay? It's the intersection between two solutions. So this guy is x is greater than or equal to 2 and x is less than 5. So you have to pick a number that both of those work for. It's got to be greater than or equal to 2 and it's got to be less than 5. Okay? So it's in between. If it's an or, it can be one or the other. So you just kind of put both of those down. So it's less than a number or it's greater than another number. So once in a while, an and will not have a solution because there will be no number. It won't be between two. It'll be like they miss each other. And the or sometimes becomes an all real solution. Okay? If they actually end up crossing. Okay? So, with and you're looking at where do they overlap, or you're looking at just putting the two graphs together on one graph. Okay. So, I remember and is between, or is split. That's how I think of them, most of the time. Sometimes you get special cases. So we have an or. So in my head, I'm thinking they should be split. Should be. Here we go. Solve them separately. So we're going to add the 5, and we're going to divide by 3. That's one answer, one solution set. Over here, we're going to subtract the 5 and divide by a negative, flip my symbol, 2. So if I grab those on the number line, I am less than or equal to 2, and I'm greater than 4. So it's split. When you have an or, you are going to be dealing with a union. Ors signify union, so you should have a union. Again, once in a while, these could go to an all real solution or an identity solution. But most of the time, you're going to get them split. And you just kind of solve them. Now, if I change the word at the very beginning and made that an and question, okay? If I were to change this and make this an and, then my solution would be no solution, right? Because there's no intersection. There's no overlap between those graphs. Does that make sense? So if you change that initial problem to an and, there is no overlap between these two graphs. They don't exist at the same time. So it can't be a solution if it's an and. There's no solution. Okay, that's when that special case would occur. All right. So this is an and. Same thing, guys. Just go ahead and buzz through this one. Okay. So do the same thing. What if I were to change the word and in the original to the or? So if I had this as an or solution. So think of the separate graphs. You'd be putting these two together as a single graph. Do you see if you put them together it become a straight line, left to right, forever? So if it were an or, you would say it's an identity. It's all reals. Okay? If it were an or. All right. If you have a compound inequality that's put together like this, if it's put together like this, it's an and. If it is put together like this, it is an and. Okay? Because we are saying this middle is greater than this left endpoint, and it's less than the right endpoint. So, what happened to this? Did we skip? We skipped one. I'm going to write in there. I think I deleted the slides when I was going through this. Okay, let's do compound. There we go. Okay. So, this is a compound, and again, it's an and, because you're already between two numbers. So we're going to solve this. You don't have to split this up. You just have to do those steps on both sides. So you're going to get the x by itself here. So what's the first thing that needs to go? Minus 3. So we're going to subtract 3 from the left endpoint and the right endpoint. So all three places are going to get the minus 3. So on the left, I end up with negative 8. I get 2x in the middle, and I get a 6 on the right. Then what's my next step to get x by itself? Divide by 2. So everything gets divided by 2. Every piece. Left side, middle, right side. Okay? So it's already set up there for you. You're already in between the two numbers. It's a compound inequality because it's all together in one. Different than when they write and or in between. Okay, the compounds are always set up for ands. Okay? All right. This is a compound. We can't solve this together, though. Do you see the problem? I can subtract 1 from both sides. That's great. Then you'd be dividing. And let's do it. Okay. So we're going to subtract 1. We're going to run into a problem here. We're going to see what happens. Now, generally, we move x's back and forth, right? You can't, because as soon as you move one, you're going to have a problem the other one. So at this point, let's go ahead and split it. Let's do this side. So I'm going to move my x over there, or vice versa, whichever way you want to move them. I'm going to divide. So I get x is less than 1/2. And over here, I'm going to solve this one. X is greater than 3. And remember, this is a word and. This is a compound inequality, so it's got to be the and. So we have 1/2, where x is less than, and we have 3, where x is greater than. Where is the overlap? Can this occur at the same time? No. So there's no solution here. There's no overlap. It's an and. It's got to have an overlap. They're not going to happen at the same time. There's no number that's in both of those groups. Okay? All right. So that's what you've learned before in Algebra 2. Okay? It's kind of a review. We're going to solve... Oh, we got one more. One more before we do something new. All right, and you've never probably seen this either. We are starting with negative 3 is less than x, which is less than 2. I want to rewrite it so that the middle is 3x plus 5. And I want you to figure out what that a and that b would be. So you're just going to do what it says, 3x plus 5. So on both sides, I'm going to multiply by 3. And I'm also going to add 1. So that the middle, I'm sorry, add 5. This next one. So you're almost like you're unsolving an equation. You're building one in the middle. So on the side here, I got -9 plus 5 is -4. We have the 3x plus 5 in the middle. And 6 plus 5 is 11. So my A is -4, my B is 11. You're just doing what it says. Do whatever to the x that it's telling you to do. I'm going to rewrite this as -3x plus 1. Okay? So we are going to multiply everything by -3. And then we are going to do what? Since we multiplied by negative, let's go ahead and just do that. This is what we have. We got to flip the symbols because we multiplied by -3. Have you ever seen an inequality written that way? Can you do that? Can you have the big guy over here and the little guy over there? You have to revolve this whole thing. -21, the smaller endpoint has to be on the left, and the bigger endpoint has to be on the right. So all we're doing is taking that whole inequality and revolving it. We flipped our symbols, and now I have to rewrite it properly. Okay? And then the last step is to add the 1. So -20 is less than -3x plus 1, which is less than -8. So you have your A and your B. Okay? Nothing crazy. Just do what it says in the middle. Apply the multiplication and the adding or subtracting. Okay? But be careful with the negatives. I'm sure there's math Excel questions. All right. Now we are going to solve polynomial inequalities. So the first thing you're going to do is move all terms to one side. So I've got an example up there. So I'm going to move that -9 over. Okay, I'm going to make it an equal sign for right now because we're going to solve these. Factor the polynomial. Do you guys know how to factor 4 terms? You remember factoring by grouping? Okay, so if you have 4 terms, how we're going to factor this is we're going to split in the middle. We're going to take the greatest common factor out of the left and take the greatest common factor out of the right. Keep in mind, if this is a minus, if the first term is a negative, you have to take that negative out. What should happen, if it can be factored, is this common factor should appear. So we have x minus 1 with both of those. So if I take it out front, I would be left with an x squared minus 9. That's how you factor by grouping. So you split it and do greatest common factor. If you don't get the same bubble, you did something wrong or it can't be factored. Can you keep factoring that? Can x squared minus 9 be factored? Yeah, it's x minus 3, x plus 3. So this is what it looks like when it's completely factored. X minus 1, x minus 3, x plus 3. Then you want to find the roots. You are finding the x-intercepts. This is where the graph hits the x-axis. So if I set x minus 1 equal to 0, I get 1. If I set x minus 3 equal to 0, I get 3, and then negative 3. So there's your points. Okay? Then you are going to use those points on a number line. Please put them in order, numerical order. not the order that they're solved. Okay, it's a number line. And then you are going to test the points. So, bring up my factor again, maybe. Here it is. All right, so you want to pick a number that is on the left in this interval between negative infinity and negative 3. Whatever number you want. Let's do negative 4. If I were to, and you just do this mentally, if I put negative 4 in here, is that a positive or a negative factor? Negative. A negative 4 and a minus 3 is still negative. Negative 4 plus 3 is still negative. If I have 3 negatives multiplied, is that a positive or a negative? Negative. Then you pick a number that's between negative 3 and positive 1. 0 is a nice number in there, right? If I put 0 in this factor, I still with negative. 0 minus 3 is still negative. 0 plus 3 is now positive. 2 negatives make a positive. And you just kind of go through this. And you're picking test points. If I put a 2 in, 2 minus 1, that's a positive. 2 minus 3 is still negative. 2 plus 3 is positive. 1 negative makes a negative. And I'm going to pick 4. If I put 4 in, 4 minus 1 is positive. 4 minus 3 is positive. 4 plus 3 is positive. Okay. Now, the original inequality said less than or equal to 0. What does that mean? What does less than 0 mean? Negative. So we are looking for when this graph is negative. So it's negative between negative infinity and negative 3, right? Or equal to. And then it becomes negative again at 1 to 3. Why would we care ever about this? Well, if you're graphing your graph here, you're placing your x-intercepts on it. This is telling me that my graph on the left side of negative 3 is negative below the x-axis. It goes above the x-axis until it gets to the 1. So we have a kind of a sketch of our graph in our head of how it's going to go up, back down, back up. Negative section, positive section, negative, and then positive. Positive, negative, positive. Negative means below x-axis, positive means above x-axis. So that's what you're going to eventually get to once you be able to graph these without a calculator. Okay? All right. So, why don't you guys try this one real quick. Factor, factor, factor. We are there with the number line. Ready to do test points? And again, you might have different test points than I do. They have to be in the interval. Maybe you use -1, or maybe you use 5 or 9. The little purple numbers don't matter. Where is it above the x-axis? From negative infinity to 1. It's just greater than, so we don't need the square brackets. Okay? That's when it's positive. This is a quadratic. So it's doing something like this, right? Okay? With this being 7 and this. Sam.
How's it positive when it's 0?
When you plug a 0 in here, that gives me a negative number here.
Yeah.
And it gives me a negative number here. So a negative times a negative. Okay, you want to count how many negatives you got. Right? Because we're multiplying them.
So you're like where you wrote the negative, 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 positive. You're getting those based off
What you
get 0
Yep.
to 8.
Yep, exactly.
And then you can use that number.
Any number that's in this interval. So I could have used negative 10. I could have used 4 in here. I could have used 10 over here. Any number within that little domain. Okay? All right. Let's go ahead and do this one real quick. First thing we're going to do is bring the 9 over. And we're going to factor. This is actually a perfect square trinomial. So that's nice. I only have one x-intercept. And it is what? Negative 3/2. Okay, you're just setting this equal to 0 and solving it. Okay, so negative 3/2. So we're going to test the point on the left of that. Give me a number less than negative 1.5. Negative 2, negative 1.5. So if I do negative 2, that's negative 4 with a 3 is a negative, and that's still going to be negative, so that's going to be positive. If I go on the right side and put a positive 2, it's still going to be positive now times a positive, which is positive. Guys, this is a square. It's a perfect square. So it doesn't matter what you put in there, you're going to get positive. So if I'm looking at this graph, it never goes negative. It's touching, but bouncing off. Do you guys remember multiplicities last year? Did you talk about multiplicities in Algebra 2? You'll talk about them this year. When you have a multiplicity, a double root or a triple root or so on, it shows up in the graph. So double roots bounce off like that. They don't cross the x-axis, they bounce. Touch it and go right off. Okay? So this is a no solution. It's never a negative graph. Never negative. And it doesn't ask you to make it equal to 0 either. So it's just less than 0. It's never going to be less than 0. All right? Are we okay with doing the factors and doing test points? Everyone understands that? I'm not going to do this one. Skip it. Okay, if we're talking rational inequality, you guys don't really have to do this, write these slides down. This is the same thing. What you want to understand with rational, so I'm just going to go to the example. This is already factored for you. Everything has to be on one side, same as before. You have to factor both top and bottom. When you factor the top and set those equal to 0, what do you get? X equals what? Negative 1 and 3. These are x-intercepts, unless they happen to be the same on the bottom, which we'll get into later. Okay? The bottom, when you set them equal to 0, you get negative 2 and 4. These are what? If the bottom goes to 0, it creates what on the graph? They're not x-intercepts. They are undefined there, which are what? Vertical asymptotes, right? You still have to test the points, because have you seen graphs where you have an asymptote up here, and then all of a sudden it jumps down below? You still have to test those, whether they're positive or negative. Okay? So we're still going to test them, but when I put my numbers on the number line, I've got negative 2, negative 1, 3, and 4. And guys, these don't have to be spread out on a perfect number line. Just put them in order. Negative 1 and negative 3 are actually x-intercepts. They are zeros. Negative 2 and 4 are not. So I would make sure on my number line that I'm testing with, I put an open circle. Okay? So, you do the same test points. Doesn't matter whether they're on top or bottom, you're still going to count the number of negatives. So if I put in, what do you want to put in here? On the left of negative 2 would be negative 3. Negative 3 on the top would be a negative. Negative 3 minus negative 3 is negative. Negative 3 plus 2 is negative. Negative 3 minus 4 is negative. 4 negatives makes a Positive region. Between -2 and -1 is, let's say, -1.5. -1.5. I'm going to kind of draw a little squiggly here. And negative or positive 1 is a negative. Negative. This is going to be positive. This is going to be negative. 3 negatives makes a negative. Let's try a 0. Zeros are easy because the signs are sitting there. So positive, negative, positive, negative. That makes a positive, 2 negatives. 3.5 gives me a positive, 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 negative. And then if I put a 5 in there, they're all positives. Okay? Everyone understand what I mean by positive and negative? I'm just looking at each factor. The question is asking what? For positives or negatives? Negatives, because it's below 0 there. Or equal to 0. So negative region here, -2, -1. Curve at -2, squared at -1. This cannot be 0. This doesn't exist on the graph. Negative over here is squared at 3, curved at 4. So again, I don't know exactly what I'm looking at here. But I know I have an asymptote here, and I have an asymptote here. My graph is above the asymptote, above the x-axis here. It goes below it here. It's going to cross here. So it's negative here, then it goes above. It's going to come down. Hit here. And continue along that asymptote, and then it comes about above the asymptote. So it's something like that. See what I'm saying? You can kind of picture things with the graph if you know the sign chart. All right. We're going to do this last one, and then we're going to be, which one do you want to do? This one or this one? That one? Okay. One side has to be 0. So we're going to move okay. And then you got to put them together as one big fraction. So we're going to find the common denominator. What's our common denominator here? There you go. So you go to each fraction. I know you can do this. This guy needs x minus 2. So on the left side, my numerator is going to be x squared plus 7x plus 10 after you FOIL that out. On the right side, be careful. There's a minus x there. So we're going to distribute. So it's going to be a negative x squared and a positive 2x. Sometimes that negative gets lost there. So when you have subtraction, make sure you kind of bring that negative up. All right. So there's our rational function that we want to test. From the top, what do you get? I mean, if you need to come over to the side and set it equal to 0, you can do that. So x equals negative 10 over 9. We have a negative 2 and a positive 2. From the bottom. So the top gives you x-intercepts, the bottom gives you asymptotes, or undefined spots. Okay? My question, is it asking for positive or negative sections? Positive. Do I care that it's just greater than? So I have no square brackets in my answers. It says greater than. No square brackets. All right. So here I go. putting in negative 3. At the top, that's going to be negative. At the bottom, it's going to be negative, negative. So that gives me a 3 negatives makes a negative. Negative 1.5. That's still going to be negative up top, negative, and then a positive. So that makes a positive. 0, positive, negative, positive. It's a negative. And again, a lot of times they just simply alternate. Sometimes they don't. If you have double roots or asymptotes, sometimes they don't alternate. So don't just assume, okay? So where is it positive? From negative 2, negative 10 over 9, and then again after 2. Okay, no square brackets because it didn't say or equal to. Does that make sense? You need to practice these. You have a Math Excel. It is due on Tuesday, I believe. Okay, so don't just ignore it this weekend. Okay.